Hi everyone, I'm trying to learn assembly language. So I'm gonna run the just a basic hello world and take a look at how compiler and how they move instructions from from the computer. I'm gonna run the command line here. I'm not familiar with the GNU debugger. I'm gonna run the manual page. So man page. That is the GNU debugger, GDB. We'll see how to run it. And they give us instructions how to run this. And also gonna see a cheat sheet here. Cheat sheet. But there are some references that we can use. And we want to use the start, I think. So we can put a breakpoint on the starting main menu. I mean, not main menu, on the starting main function. So we're gonna start GDB, and we're gonna start executing the program here. And then we're gonna put start. So you will find the location where it will start. Let's see if they have. It doesn't show it here. Let's see. It's just basic one. We just look at the manual page here. So assume. And you can look for start. Yep. And you see start. Start your program with argument will specify. Basically, it will run and stop at the starting point. So in the interactive message, put back here, we'll just put start. Temporarily breakpoint 1 at this memory address. So the main CPP file is located on this memory address. And line 5. We do not have the code, so let's display the source code here. Layout source and layout source. There we go. I'm gonna lay out the source. We want to see. Let's backtrack here a little bit. Let's take a look at the assembly. Let's disassemble the main function. Disassemble. Okay. This is where the print line is. We kind of know that we call. So we'll let's take a look at this. So call. What does the call mean? Procedure call instruction do not have any solution. A call basically push return address and jump to label. That's what call is doing. Procedural call. Let's see. Here we go. Calling a function. Call a function. That's what it does. Call a function. And this is the memory address located on this address. And as you see, the first one is the source. S means source, D means destination. So the source goes to first and destination goes to second. And this is the register. It's on the CPU. The register are located on the CPU. And they're a special register that we're not supposed to use. Let's see, what is this register here? RBP. Oops. Let's not look. Let's see, what is this? Writing to a function. If function going to use any callee safe register, you're going to use the RBP here. And what is register RBP? Let's look at Harvard. Let's see if they have it. RBP. RBP is for base pointer general purpose for some compiler, so it's not restricted. Basically, just to hold informations. Assembly language, basically, there's no set of rules, so you can move things, you can move the data around from one registry to another registry. So you, as the programmer, has to keep track what's going on. So it's more freedom and less restrictive as C++ or C language. So this is general purpose registry we can use. You know what? I might save this page. That would be a good page here. We'll save that page as a reference. So it's push this instruction to this registry. Basically push there. Now move. So you're gonna move this function. Let's see what is in ER64. Let's see what it is. What is 64? Terminate an indirect branch in 64-bit mode. I just basically break terminating and branch. So, okay. All right. So we just push whatever the main function into this stack to the register. So it hold in this register basically RBP. Then they're gonna move from RBP to RSP. So that's what it does. So it move the move function. Let's see. Move function going to be, it's like go-to function basically. Move instruction move. So move source to destination. That's what it does. So just move your source. Move this source here. Move source. Oh, and that's the destination. And that's the source. And move it to the destination. And after that, we're gonna put sub. I think I'll subtract. I'll prepare subtract source from destinations. Okay. That's that's a return. That's a return. I believe that's return. Return address from the stack. So pop the address. let's subtract the source. Let's see what happened here. Subtract. What's the subtract? Subtract source from destination. Subtract this address from the destination. And then move this address. So move this address into here and subtracting it. And then what is this does here? Leave. Oh, and move from the stack. Apparently it's this one here. It's move from the stack. Okay. Oops. Oh no. Let's see, where is my page there? And tutorial. It's open. And this assembly language cheat sheet. It's from assembly language cheat sheet. It's from I think Brown University. Remove. That's the source. You move from the source to the destination. This is the job instruction. Subtract source to destinations. Inward operation. Okay. Okay, let's see. I just move next. So I'm going to return. Yeah, which is that leave the function. What's next? Finish. Let's try. We can run it again. And yes. So basically, that just goes directly there. Or just the object, and no, you cannot. Let me see what we can do here. What other? Now we can open stack frame. Okay, let's see. I'm gonna do a call stack. Previews. Oh, wait a minute. Previews here. Display program stack. I think that's what a call stack is. Okay, call stack on GDB. So call stack, we're just gonna use the gonna backtrace it. So let's go back. That's in the call stack. I want to display something here. I think you can display the memory address. It should be able to do that. I don't remember how. Display. Let me see. Oh. Info. Let's see what we have here. Info. We'll see what we can use. Info. What's this info address? Let's see. Oh. Let's call stack again. On the frame. Info address. We want to put the address there. 0x7. How many are there? 1, 1, 2, 3, 4, 5, 6, 7, 2, 3, 4, 5, 6, 7, 8, 8. Let's see if I can show layout. What's the layout? I think I have the layout. Yes, there you go. I'm gonna lay out the assembly. I think you can trace it. Is that I step through? What is all the instructions they provide since the beginning? I want to find out info. Once again, address discover the symbol is store. Okay. Info. What does info does? Let's see. Next. Info. No. There we go. Full documentation. You have the info of the debug. Command info GDB. Give access complete menu. Also. Info GDB. I think it's the same one. Oops. Let's see. Manual page info. register. Okay, there's not much information about hello world. Where is the hello world is printed? I think this is where the print functions. I don't know where do you put that hello world. Couldn't find a string here. Okay. Source. No, I don't want the source. I want to find where the output. You just change the source. That's where you're gonna print it. In this function call here is printing the content function, and that display the message to the screen there. Call is the function call, doing that basically. Using start frame, when you have set up start frame, you can use it to store and access local variable. Do that. When call function is executed, the address of the following instruction is pushed onto the stack as return address. Address. And so, okay, let's continue. That is your return. Leaf. Leaf. I think so. That is leafing. Cleaning up basically. It does the cleaning up. Remove that to the destination address. So RAX is the destination address. I think that's cleaning it. The RAX. Make sure the value type and align on allocate space. Remove that for this. 8 byte register. Can be expressed as array stored in racks and index. Okay. So this is basically all the program are stored in the memory. Okay. Let's create another program here. Let's just go to name. Let's put some number. Let's create variable. I equal to 1. Character is h equal to a. We want to say a. And we'll say if we compare is I, fn ch, and then we will do this. Because what happened here? Oh. So if I less than character a, and that. Okay, let's exit and save. for command run. We run the all the warning. Let's do verbose. Let's do what's the standard C? I'm gonna use a standard C 11. What other arguments should we use? I think that's it. Main, let's see. In the output file, we're gonna test it. Test. We'll just put test. So now we have test. We're gonna run the debugger. Even G or not. I don't remember if we put debug or not. Yeah, we forgot to put debug. So we have to have G option to debug. Otherwise, the GNU debugger will not give us any information. So we'll compile it one more time. And we will run the test binary file. And we'll execute this binary. Okay. And use the start. Or we can just put main. I think we can search for main. See how we do that. No. Okay, that's fair. Go back here. Start your program by specifying behavior. Attach process 1 to 3. Started by point. A program step. Okay. Option. Start. Start will be good. We will start temporarily break at 1. Oh, you want? I forgot to show the source. Yeah. There we go. So now let's stop at this integer. Print. I'm gonna print I. Print I. There you go. What does print do? I think it prints the configuration. What does the just to print the value of I? I'm gonna look at print I. Let's see. Where's my GNU? It should. Alright, I'm gonna references. I think this is more. A lot of information just could be good. Print. Okay, print. What does it do? Where's all the frame stat? On there. Print. Show value. There you go. That's right. Print will show value of expression or the value of that. Okay. That's interesting. It does not print the value of 1. Okay, let's see where that value 1 located. Oops. Where is 1? 1 is 0, 0, 0, 1, right? What is 1? This is 1. That's 1 in hexadecimal. Let's see. 1 in hexadecimal. Oh, gamma. Now 1 is in decimal. 1. Hexadecimal is 1, which is that one. Yep. Hexadecimal 1, that's hexadecimal. Now, if we have, what is that? X61. We want to put 61. What is 61? That's 97. 97. What is 65? I know that small a is an ASCII. Let's see. ASCII. A is 132 or 65. I think that's the number. There we go. ASCII. ASCII code. A. Small a. Big A is 65. Actually, small a is 97. Oops. The small a is 97 here. You can see small a is 97. Right here is 97. And we found out that 97 is here. So move B to this. This is the character A. Character A is 61. So that's the character A. So let's see. What's the next one? Will be N. And we'll print it. We'll print it. And when you print it, it's 377. Not sure why it shows 377 instead of 97 there. Let's see. Let's do that. White battery still there. Let's use each it again. Texas. Where's the Texas? Oh, there I have more. Stack. Display program stack. Okay, program stack. We want to see the frame. So the frame. I think we put frames. Okay. For main. Let's see. And like the number of frame or the frame at address there. This is the address here. I don't remember what's the okay, that's this is here. I'll highlight this. This is the value of this address. Print that address and copy paste it with I want to say frame like frame number or frame at address. Frame at address. Okay. The next. Four. That's one. At the ice one. There you go. That's what I'm trying to say. So when we print the value I, supposed to come up with 1. And when you print the value of ch is 97. So meaning 1 is less than 97. So you'll print this hello. Let's see. I want to show. Where's that at? On next. Gonna print that. Let me show this assembly again. We will show the assembly. Okay, let's see this one here. Assembly. I want to see this is. I want to disassemble this printf function here. Or do that. Now, let's see what is this here. I want to see that value is d0. It's d0. Let's see what is d0. d0. 208. Decimal of 208. Not sure what the value is for. Let's see. ASCII. Table. ASCII table. Ooh, there you go. Let's see what is the value of 208. I want to see what the value 208. It's a D. That's interesting. And move this address. Oh wait, JB. What is JB? It's jump, basically jump from one address to print. So we're gonna jump from this address source jump to this print. Okay. So we are assemble this print function. We want to see what's going on inside this print. What is that 88? It's supposed to say each character is supposed to show a 168. 168. What is big H? Right here. It's 48. It's 48. Let's see. Let's put 48. What's in decimal? 30. We need 30 here. 30. No. Oh. Okay, what is this? I think this is the value here. 31. Huh. What is 31 in hexadecimal? 49. No, 49 is high. No. It's 56. 7. F. What is 7? F. 127. 7F. 7F is. Thinking at the 7F is 127 in decimal. 27 is the leap. That's not right. I'm trying to find where this hello is located. Yeah. Okay, here's another print. Here's another print. 31, you see here? 31. No. What's the 30? What's the number for H for hello? Decimals 48. E. Alright, but E 65. That's the hexadecimal. That failed. Print internal. Um, W. Yeah, small W. Yeah, small W. W. What? 77. 77. No. It's basically it's printing. I tell. It's not as friendly as Microsoft. When you look at Microsoft, it will tell you the character. It'll display the character. So this is kind of hard to tell what this hello world is printed. I will say this assemble. I want to see. Oh, source. Oh, okay. Let's see the register here. 197. Yeah, let's decipher this code. Hello. So we know H is what is L? L is 6C. Is there anything 6C here? 6C is supposed to show. Nope, there is no 6C. W is 77. Oh, hard to tell too. From left to right. I mean, from the right to left. Yeah, tell. Oh, here we go. You need to click gradient. That's the main. Uh, register. Is it different than previous one? Yeah, a little bit different. Next. Okay, cannot tell anything else. Alright. Alright, let's see. I need to find out where. All these things and okay. Follow all these things. Top info. Okay. Okay. Info. Okay. Nothing else I can take a look at information here. There's not much information for me to go on this. Okay. Peace. Wait, peace. Peace. Yes, is he done? Temporary address there. I need to go to the next one first. Then you can put it. There we go. I can see that, but not the hello world. I have to figure out how I can see this hello world in there. Let's look at. I'm sure there's a program that already did. Hello world. Hello. In memory stack. In register. Register or something like that. In example, hello world. Location in register. Or anymore. Oh, GDB. Okay, let's see if that come out something. Let's see, here. Stack RAM. Call stack RAM divided into contiguous piece of stack RAM. Okay. What? backtrace in, print only the innermost in frame. Mm-hmm. How do you do this here? Oh, it tells you that. Okay, what is P? P? P. Oh, so what does P stand for? Yeah, let me dump that again. I think you can put this P. I think if you put the let's look at that RAX. Okay, the P R A X. I want to see what's in there inside that inside this registry. I want to see what's on there. REX. I already gone. Is this number here? Or they move this. They move that to this EX. So let's see P. Let's see what's on that. Into EX. Ah, not sure what it is. P. Okay. Good information. Runtime stack. This is MIT. Oh, this is Stanford. Stanford website. This is pretty neat. Okay. It's Bluetooth. Okay, that's right. Alright. P. Info register. Command display current value for all integer register. Use example P fact to print the value from the single register. That's what it is. So print that. I think this is a good reference to. We'll save this. This is from Stanford University. From Stanford. No. Let's see. I think that's it. What else can we look? You know what? Maybe I need to give it a name, like a variable. But it's supposed to show. Did you remember the access to the register of the name instead of most familiar name? Okay. Register is okay. Then display step expression to be repeated, evaluated, single step. To display with an argument list all the correct expression to display. Alright. Nothing. It's still here. Right? Okay. Well, now. Okay, let's print that. Not print that P. What is that? What's the values there? P is, so we are on this back here. RIP. Let's see what's on there. our IP is a big function. Our AX 97. So our AX is 97, which is the CH. CH. Okay. Let's see, remove AX. This RDI. What's on there? 1. P. Let's see, what is AX? Yes, 7 again. Basically, just move from one memory, one registry to another registry. Great. Okay. It's no more RBP. I want to see what RBP. P RBP. Hey, that's the void. I don't need that. Okay, I think that's it. I can. That's all the information I can extract from this. So couldn't figure out how can I locate what's this hello. This one here, you can put REX, and then you find out where it is. What is T again? RAX. So I want to see what is that. I guess it's RAX. RAX. Oh. Let's bring it. We can do this. Oh, are we gonna? I saw that was at that time. Okay, stack mechanic. Command. Display background. Oh. Let's see. Project squadron. The address, the content. Address and content. Address and content. How do you display this? I display divide. Okay. Let's see, what is that? You can overstack here. Here's some information. Put an assembly instruction. Next display layout. AS different assembly. Previous source display source window SRC. No. It's not pilot. Yeah. The interface here. Like system display system register. And that's it. Alright, well, if you've been watching until here, thank you. Try to find out where that location is. I could just put it as a variable so we can see. When you put everything in a variable, it's easier to see, but you know. Alright, that will be another next time.